Since the original development of gas chromatography, many chromatographers have believed that hydrogen is the best carrier gas for GC analysis. In many applications, hydrogen can be the carrier gas of choice because of the combination of fast analysis, high efficiency, and reduced costs. However, helium is still by far the most commonly used carrier gas because it is inert and non-flammable and possesses physical properties that permit fast, high-resolution, temperature-programmed gas chromatography. As one of the global leaders in helium supply, Air Products estimates that at today's demand level, known helium reserves will last for approximately 300 years. When new helium reserves come on stream, world supply will exceed expected demand. The recent temporary supply shortages have prompted some chromatographers to re-examine the benefits of hydrogen as an alternative carrier gas. Although hydrogen is flammable, its high diffusivity allows faster linear velocities and consequent shorter analysis times, with typically the same separation efficiency that is provided by helium. In this video, we will review the different carrier gases used in gas chromatography, the purity requirements for hydrogen, and the different modes of supply. We will compare the cylinders that are most frequently used in laboratories with hydrogen generators. For example, in these chromatograms using the same column and conditions, you can see the differences using hydrogen, helium, and nitrogen as carrier gases in temperature-programmed capillary GC. Notice the differences in the retention times and resolution. Faster analyses translate into increased throughput, which means lower cost per sample. In some situations, reactivity could be a problem when using hydrogen as the mobile phase. An example is the catalytic hydrogenation of unsaturated hydrocarbons under certain conditions. The potential for chemical reactions in your analytical system must be considered. There are also some issues in using hydrogen as the mobile phase in GCMS. Speak to your GC supplier for advice. Responding to the increased interest in hydrogen as a carrier gas, Air Products has undertaken extensive research on alternative methods of providing a consistent, ultra-high purity source of hydrogen that will be perfect for modern high-precision gas chromatography. The best solution currently on the market is the hydrogen BIP cylinder. Besides being filled with ultra-high purity hydrogen, there is an internal purifier system and unique valve design that achieves ultra-low impurity specifications that are not possible from any other technology. It's not only about changing to hydrogen, but about selecting the right quality of hydrogen. In this table, you can clearly see that the critical impurities of oxygen, water, and hydrocarbons are up to 100 times lower in hydrogen BIP than in conventional hydrogen 5.0, the most common purity used in laboratories worldwide. These specifications for hydrogen BIP make it the perfect choice both as a fuel and carrier gas. This chromatogram shows the typical results for GC-FID when using hydrogen BIP both as a fuel and carrier gas compared with using hydrogen technical grade. You can see the difference between using the different purities of hydrogen, both in terms of baseline noise and column bleed. Hydrogen generators offer an alternative supply option for GC carrier and fuel gases, and we will now consider their relative advantages and disadvantages against cylinders. First, the advantages. They are a good solution in extremely remote locations where cylinder supply is difficult or impossible. They produce hydrogen on demand, so little hydrogen is stored. They operate at low pressures and do not require high pressure regulators. The disadvantages of hydrogen generators are hydrogen generators are usually much more expensive than hydrogen cylinder supply. Even the best hydrogen generators can fail catastrophically without any warning, so backup cylinder supply is strongly recommended. Many hydrogen generators are not suitable for gas chromatography. Before purchasing, the generator specifications must be checked carefully. Most manufacturers only give either the oxygen or water impurity levels, not both. Deionizer bags purify the demineralized water supply. These must be changed often, as recommended by the manufacturer, or the generator will be severely damaged. In summary, hydrogen can be successfully used as a carrier gas in gas chromatography to give fast and accurate analyses. However, helium continues to be the carrier gas of choice for most chromatographers because it is inert and non-flammable and permits high-resolution, temperature-programmed gas chromatography.